Hi, it's me and welcome to my channel. In the Carboniferous period, which lasted from about 360 to 299 million years ago, giant dragonflies were among the top predators on land and in the air. They could grow up to 71 centimeters long with a wingspan of almost a meter. And they weren't alone. Other insects like cockroaches and the ancestors of termites reached gigantic proportions too. But then something happened. Toward the end of the period, these giants abruptly disappeared from the fossil record. A mass extinction that wiped out around 70% of all species may have been the culprit. And new research says that one of the reasons for this mass extinction was that there was less oxygen in the air. So let us dive into what we know about this mysterious insect apocalypse and what we can learn from it. Now, technically, this wasn't an extinction of all insects, but rather a mass extinction specifically of large insects. After the Carboniferous, smaller insects took over, and it would take another 30 million years before insects got big again. But why did so many of the biggest bugs die off? Well, the leading hypothesis is that it had something to do with oxygen. See, insects breathe through a system of tubes called trachea. These tubes are connected to openings along an insect's body called spiracles. Unlike vertebrates, insects don't have lungs or a circulatory system to pump their blood. So the air that enters their bodies doesn't go through a sophisticated set of filters. It just enters the trachea directly and diffuses throughout their tissues. This works fine when you're small, but scientists think that this simple respiratory system was a limiting factor for giant insects. As an insect grows, it needs more oxygen to support its larger body. So to keep up with their growing demand, insects could either increase the amount of oxygen that enters their body by increasing the size of their spiracles, or they could reduce the distance that oxygen has to travel through their body by adding more tracheal tubes. But there's a trade-off here. Increasing the number of tubes comes with risks. More spiracles mean more holes in an insect's body, making it more vulnerable to dehydration and attacks from predators. As far as we can tell, giant insects like today's stick and leaf insects manage this problem by creating armor-like plates to cover their spiracles when needed. But there seems to be a limit to how many holes you can punch in your personal security detail. It looks like the respiratory challenges didn't stop insects from getting big, at least not yet. But even though giant insects persisted throughout most of the Carboniferous, oxygen levels were dropping. In fact, atmospheric oxygen levels dropped to less than half of what they are now. Now, scientists aren't sure exactly how fast this decline happened. Some estimates say that it dropped by 20% or more every 10 million years, while others say it happened more gradually over tens of millions of years. But regardless, this drop did not affect all insects equally. For example, close relatives of modern dragonflies known as the Meganostoptera were some of the biggest insects alive, growing up to 37 centimeters long with a wingspan of up to 64 centimeters, and those giants disappeared at the end of the Carboniferous, but other insects like cockroaches survived. Scientists think it might have something to do with where they lived. Dragonflies and mayflies mostly lived in what we today call the Northern Hemisphere, while cockroaches were more widespread. Their global distribution could have helped them survive because they were already adapted to lower oxygen levels thanks to living in higher latitudes. Meanwhile, the disappearance of giant dragonflies left smaller insects like true bugs and beetles to become the dominant land predators. And it would stay that way until the late Triassic, when the first dinosaurs arrived on the scene. But the story of the insect apocalypse doesn't end there. You see, we know that declining oxygen levels played a role in the mass extinction, but we've been a little fuzzy on the details. Like, yeah, less oxygen is bad. How exactly did it cause this mass extinction? Did insects simply suffocate overnight? Or did more subtle changes slowly weaken them over time? Well, a new study published this week in the journal PNAS proposes that a gradual decline in oxygen created a positive feedback loop that ended in a sudden collapse. The team started by looking at fossil evidence for the mass extinction of giant insects. To date, scientists have found no insect fossils older than 305 million years that show clear evidence of respiratory damage, like air sacs that have collapsed or blocked trachea. So the researchers decided to recreate the atmospheres of the early and late Carboniferous and expose insect larvae to them to see how well they could breathe. They also looked at a gene called TSP1, which plays a key role in building the scaffolding for an insect's tracheal system. When the researchers exposed their insect larvae to low oxygen conditions, they found that one of the simulated atmospheres was basically a death sentence for the insects, even though it was a relatively slow decline that occurred over a time scale similar to the real world. They found that instead of ramping up their breathing, these insects panicked and used most of their energy trying to get more oxygen, which probably isn't a sustainable strategy. And they discovered that low oxygen conditions changed the activity of genes related to respiration and development. Specifically, they found that one version of the TSP1 gene performed worse at lower oxygen levels, which means that instead of adapting to changing conditions over time, giant insects may have just gotten worse at breathing. This respiratory impairment may have made them more vulnerable to the other environmental challenges that came with less oxygen, like less food and more droughts, essentially creating a downward spiral. And since giant insects were already in their twilight years, there wasn't enough time for evolution to give them a last-minute superpower to save them. And while this study focused on dragonflies, the researchers think that their results could apply to other giant insects as well. All told, this study paints a pretty bleak picture of what life was like at the end of the Carboniferous. But it does have some surprising upsides. First of all, this isn't the first time that declining oxygen levels caused a mass extinction. There was also a similar event during the Permian period, which wiped out around 90% of marine species and 70% of terrestrial vertebrates. So understanding the causes of this ancient insect apocalypse could help us predict how current changes in oxygen levels might impact animals today. What's more, scientists used to think that insects would start suffocating if oxygen levels dropped below 15%. But this study suggests that it's a more complicated issue. Insects might be able to cope with declining oxygen levels for a while, but then experience a sudden decline in fitness that ends in a mass extinction. And finally, this is a good reminder that ecological dominators aren't invincible. Just ask the dinosaurs. So thanks for watching this episode of SciShow. And thank you to one of our patrons for asking this question. Patrons can submit questions to our inbox, and our editors pick out the best ones to answer in episodes like this one. And this only scratches the surface of what we have over at Patreon. If you'd like to check out what else we have, you can visit our page.